And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're going to be taking a look at this Linto phono preamp. Let's get into it. Right, this is a Linto. It belongs to Dan, who is increasingly worried about it having a problem with its power supply. He said he's had it apart and it's got signs of leakage inside, so he's quite worried about that. We've got a very chewed up fuse holder, usual Linn style of case. Linto celebrates the 25th anniversary of the Linn Sondek LP12 transcription turntable. Okay. I'm not going to pass comments. Right, let's get it apart and see what's going on. Dan has had it apart. I believe it's dead, but let's just have a little look before we go mad. And I believe it's fitted with a Brilliant power supply. So yeah, let's see what's going on. Okay, as I thought, a big empty box. So what have we got that's leaking moisture? Got our usual Brilliant power supply with a little sniff. Can't see anything leaking moisture. How is the Brilliant secured to countersunk screws? Okay, right, we know these Brilliants do suffer, but I don't know of any difference between this Brilliant and something that, say, for example, you'd have in a Carrick. Now, clearly he hasn't been in the Brilliant because it's all still intact. So bottom plug is the switch, top one is the power coming in. Come on, out you come. So first thing I want to do is just inspect the Brilliant. Some signs of some discolouring in there, maybe? I don't know what's underneath there. Should we just have a quick look? It's a reasonably easy job to fetch it out, I'd imagine. As with most stuff Linn, these are M3 screws. I mean, there's some signs. You can catch that in the light. You can sort of see a tide mark there. But I've got a sneaking suspicion that's where the PCB went through a cleaning cycle after they finished, just to erase the flux. We'll take it apart and check it anyway. But what does concern me more than anything else, I think, is the Brilliant. So let's put this to one side. Let's pop that back in on a few screws just to hold it down, while we take a look at the Brilliant, sorry. And we'll go from there. We need to get these little rivets to pop apart. This isn't the easiest job in the world, although this one, they haven't gone yellow yet, which is an encouraging sign that they might still be okay and not extremely brittle. I've still got to get that one out, haven't I? Right. The ideal solution is, of course, to repair the original. But we do have the sort of Doz's Television Workshop hybrid power supply that did work in the Carrick. I'll need to confirm, but it's the same Brilliant, except for this one, if you can see on it, does say phono on the end of this thing there, so maybe there are subtle differences we are unaware of. Okay. Okay, we have had a major burn up there. Something has been very warm. Yeah. So as you can see, we've had a massive burn up in the supply. 18, 19, 26 and 27 have gone up in flames. Now, how much electrolyte leakage have we got in here? Let's have a quick run round with the peak meter and see if this output, because if this output stage is leaking like a sieve, then I don't think I'm going to investigate this front. I seem to remember these power supply chips not being available. That's okay. That's okay. That's good. So that is all good. Right, so we've got a catastrophic failure in the primary somewhere. Let's go and see if I've got a schematic, and if I have, find out what R's 18, 19, 26 and 27 are doing. Feeding, by the look of it, one of those choppers actually. Let's have a quick look at that, see if it's still a transistor or it's turned into something rubbish. Oh dear. Oh dear, oh dear, oh dear. Where's the other one? Over here. Oh dear, oh dear. Right, that's an awful lot of short circuits, so that's going to be our root cause. What caused it to fail? Who knows, but we need 2 FETs, which won't be difficult. Let's see what the output stage is looking like. Okay, okay, okay. So the output stage, for once in its life, is absolutely fine. Let's see what else we've got. Possibly, oh dear, oh dear. Oh, might be all right. Okay, so something has failed catastrophically and stopped play. So let's see if I can find a schematic and then make a decision which direction to go. Right, it's actually a few weeks later, and try as I might, I can't find any schematics for the Square Brilliant. I have, however, found a schematic for the Linto itself, and unlike your usual Brilliant that features in the Carrick, etc., the square or the round one, the round one being the U25W that we did recently with a Carrick, this one produces 2 bipolar supplies, so it's about plus minus 12 volts and plus minus 24 as far as I can make out, whereas the usual Brilliant just produces plus minus 24 and plus 10. There's also a power good rail out, certainly on this one, not sure about Carrick, But yeah, this one, as you can see, if I hold it, if I can get it in focus, there you go. It does say /phono on the output, and that makes this a bit different. Now, because I found the Linto schematic, I've been through that, and yeah, if we just hop over to the computer, I'll show you what I've come up with. Okay, so because we can't find a schematic, what I've done is I've designed a very simple filter and rectifier circuit here that will give us plus minus 24 and plus minus 24 minus the voltage across these. This is really just to improve the filtration situation, because this slightly lower balanced supply that comes out down here feeds the first stage of the phono. Now that needs to be quite well filtered, so hopefully we've accomplished that. This is a bit of a, there's 2 pins here that we can use to add some more filtration in if we need to, and these values might change yet if I haven't guessed it right, because it is that I don't know how much current this thing is going to consume. So the other thing that is this is our delayed output, which should give us a power good signal on there to bring the preamplifier out of mute. Obviously we need our rails to be established and happy before we switch the preamp on, and that's just there to stop a sort of bump in the speakers as you switch the thing on, which would be suboptimal. So I've conjured up this little PCB here, and it's got some surface mount on it, because that's easy to do even for somebody of my shaky nature. So yeah, it's called the Not Brill Linto edition, and it's very similar to the square Brilliant Carrick thing I built, except for Carrick had the 10 volt rail. So all it is a rectifier and filter assembly, and we've got a bit of trickery around here to give us a power good output. So yeah, this is a bit of an experiment. I can't fix the Brilliant. There are no schematics for this. It's so badly damaged I can't reverse engineer it. So what have we got to lose at this point? Nothing. So let's put it together and give it a go. Right, just start by adding a couple of dots of solder paste to the board where we want our components. These are all 100 nanofarad parts. Okay, let's just pop the hot air gun on. On an airspeed of 4, whatever that means, but we want a bit less than that. It's tending to blow the component off the board. Yeah, a bit less than that. We're on 2 now. Go. Perhaps we want less airspeed than 2. There we go. So that should be good, but as ever, let's have a little inspect. Is it hot enough? No, it's cool enough to pick up. We're all good. Anything that I'm not entirely convinced about, I shall rework. I have to say, yeah, C12 at one end, not quite entirely convinced about that. Just widen the angle a bit, just touch that up. Perfect. Yeah. Not exactly aerospace quality, but I think it'll do. Close enough for government work, as the phrase goes. So I've just got my flux again. Let me zoom back in. Where are you? You're over there. I'm going to put in the snubber capacitors for the rectifier. These are a different value. These are 10 nanofarads. Damn it, my tweezers have become sticky with flux. I should have cleaned them. Come on off, come on. Off you come. There it is. I'm just going to clean those with a bit of IPA. There we go. Jostled them into place. And again, let's have a brief inspection. That's fine. By the way, this is lead free as well, this stuff, so yeah. Right, I'm going to put the 100 nanofarads away. We've just got 10 nanofarads. I've got 2 surface mount devices to fit. 2 surface mount resistors, R1 which is 10k and R2 which is 270k. We'll do R1 first, which is 10k. Crikey, don't want to be mislaying one of those, do I? R1, 10k. Okay, again, we'll just have a little look at that. I'm just going to touch it up at one end with the iron. No, it's fine. And then R2, which is 270k. Couple of spots of solder paste. That looks to have got it. Just just have a little look at that. Again, just not quite happy with the one end. Not happy with either end. That's it. Right, so that's got all the surface mounts on bar this transistor down here, because I'm just waiting for RS to deliver it. So stand by. Right, it isn't later on that day, it's a few weeks later actually. Stuff got in the way, but RS were very prompt in delivering a few bits and pieces. You'll notice on the bench I've got the digital microscope out. Now hopefully this is recording, however it was very cheap from AliExpress, and it's not the most reliable bit of kit in the land. In fact, I don't think it's ever managed to appear on the channel before, so this will be a first. Anyway, we've got a lot of little transistors here, of which I want one. So I'm just going to extract it from its packaging there. Gonna get it in the tweezers, and we're going to fire it right across the workshop. There we go. That's it there. I forget what they are now. Are they BC5 80847s? BC847B. There you go. So let's just look at the state of the tweezers under the microscope. If the footage has come out, they need a little tweaking. There we go. Let's just get that into some semblance of a position. I'm actually going to attempt to hand solder this fella in place. Those pads aren't great, are they? Seems to be they're a little bit wide at the base. The right hand side's ground anyway, so maybe I'm not worried about that. I've got a fresh new tip. I've had a lot of tip failures lately. Spent a fortune with Mr. Metcal. I have to say though, they're not expensive really in the grand scheme of things, and they do last a good while. Right, let's dob a bit of flux in there. I'm not very happy with that pad layout there at all. I mean, it'll work, but oh god, there's masses. Masses of flux. There's enough there to do 45 blasted transistors. Warm it up, it'll soon disappear. And let's just warm some of this flux up and just get it out of the way a bit. See where our transistor is then. Okay, it's starting to come good. Let's see, it needs to rotate around a little. A lot. God, there's masses in there. I've completely made a mess of that. See, what I'm going to do is I'm actually going to turn this board round and solder the top pin on first. Where are we? We're down here. There we are. So let's see if we can just clean that up again. See if we've got the first pin in the right place. Yeah, it's looking somewhere near. I can tweak it round once I've made a mechanical joint there. That's it. Too far the wrong way. I have to say, working with these LCD microscopes takes a bit of getting used to. What I'm used to doing is a stereoscopic optical scope, where of course you've got a bit of depth perception, but these aren't bad once you get into it. And it's great for working on this smaller stuff. Wish I'd put a BC507 or something in there. There we go. That's somewhere near. Right, let's pop it round the other way. Where am I? There I am. Yeah, you can see those two pads aren't a great alignment. I must have picked an incorrect footprint when I laid the board out. Still, it'll work. It'll be okay. It's got the one there. Is that down? Not sure it is. Fairly sure it is now. Just remake that top joint again just to make sure. Pretty good, I reckon. Let's clean some of that flux off and see what it looks like. I shall use some IPA and a little stubbly brush. Let's just have a look at that under the scope again. Let's just blow that flux or residue of IPA out of the way. Not sure it's the greatest job in the world, is it really? I think that'll do. Let's just have a little inspect with some real eyes in stereoscopic vision. Yeah, I'm pretty happy with that. Just going to get on with the rest of it, I suppose. So I'm just going to pop the microscope out of the way, stop it recording first. Hopefully that footage has come out. What joys have I got left? Let's have the bench light back on now I'm not dealing with a microscope. We got 4 bloody great big diodes, because these are super fast recovery things. So, you know, audiophiles like that sort of gumph. So let's get ourselves 4 of these. Massive overkill. And these are UF5408s. I'm tempted to use the little leg forming tool here. Yeah, why not? That's just something I found online, by the way. It was on Thingiverse or something, and handy for this sort of job. Makes a neater job of it, doesn't it? So install the diodes. It doesn't make a neater job of it because you just fit in anyway. Yeah, we're there. That's okay. Okay, what have we got left to fit? The electrolytic capacitors, some pins there. That is a 5-volt Zener diode, so let's fit that first. And I thought that was kicking around. I think this is a 5-volt Zener. And the way I'm just going to check that is I'm actually going to put it on my current, going to put it on the lab power supply and seriously current limit that to a milliamp or so. There we go. We should turn that down to 6 volts. I'm just going to connect my diode, and that's brought the voltage down. The power supply had about 7 or 8 volts on there. It's brought it down to 5.19. So yep, that is our Zener. So that goes in that way around. If you want to know how to do that, by the way, because I did hope that the little sort of AliExpress come eBay testers that I've got would test the Zener, but they don't. Same as the... Actually, I didn't try the Peak. Job for another day. But if you want to know how to test the Zener using nothing but a lab power supply, drop a comment below, and I'll go through with it at one stage. But just for now, I want to get this built. Right, that is the Zener in place. Then we've just got the larger value of electrolytics. I believe these are 1000 mic at 35 volts. Yep, 1000 mic, 35 volts. So these are going to live in here. That's a bit of a worry. I appear to be one short. How have I managed that? Right, did I only order 5 of those? Let me just go and check. And it turns out they're on back order. Or they were. They should be with me any day now. This job's taking forever. I might see if I've got another 1000 mic cap I can just strap in there for now. Because we need to make some measurements of this board. To actually make sure. Because I need to know how much power the Linto itself consumes. And to do so, I'm going to hook DC into this. So we get the right output voltages, measure the power and rate a transformer accordingly. So I'm just going to have a dig in my box and see if I've got one capacitor that I can just put in there for now. So 1000 mic, what have I got? I've got this 50 volt thing. I'm just going to hang it in there for now and take it out after I've made the measurements and the other ones are with me. Oh, why didn't I pay attention to the back order status? Never mind. Right. Well, that's ghastly, isn't it? Still, it'll do for now. Okay, that is going to be a wire link for now. We've got this capacitor over here. Let me go back to my schematic and find out what that's supposed to be. That is going to be, oh, it's a 10 mic. So, did I buy those? This is actually 33 mic, but if it goes in the hole, it'll do to test. This is just going to increase the delay output. And it fits in there nicely, so yeah. Okay, that sort of looks okay. So get rid of all this. Legs. Wire links I've got to put in. I've got to put one in there. In fact, while I've got some legs here, I might as well use those. One in there. And then I'm just going to put 2 wire links in place of here. What's going to go in here in the final version is some sensibly rated fuses. So I just want to pop those in for now, and I will replace those with some fuses when I know how much current we're going to be drawing. It's also going to be a convenient place actually for me to just click my power supply on until we know what's going on. Next thing I need to do is actually recycle the connector off the Brilliant. Yeah, I think it's time for a cup of tea though. Right, time for testing. Now I've slightly altered my game plan when I was having a cup of tea, and I've got this Romarsh transformer out of my junk box, and this has got 220 volt primaries, 0 to 255 volts, 11 milliamps, so it's probably for some tube piece of equipment, 40 volts, half an amp, bias filaments maybe. Haven't really got a filament winding as such, unless we want 12 volt filaments. When we got 0, 12, 0, 12, 1.5 amps, that's what I'm going to use. So the 220 volt, sorry, the 2 120 volt windings I've connected in series previously, so that gives us 240 volts, so I can go in there. That's going to be our mains input, and our output I want 0, 12. So if I couple these two together, this is actually going to be our 0 point, and then I'll have 12 volts out of phase and 12 volts in phase here. Feed that into these 2 points here, which will then feed the rectifiers and should give me some output voltage here. Now why I'm doing that is because the action of the diode losses, we should end up with a peak voltage minus the diode voltages at the output. And looking at the Linto schematic, it's only one rail I'm looking at, not via these 2 resistors. By the way, these are shown as 47 ohms on the schematic, but I don't know what they're going to be yet. So I've gone high for the time being at 120 ohms, but that's not going to happen until it's loaded up. The Linto itself has a lot of post-regulation after what would have been the Brilliant switched mode. So I'm not particularly worried about being so accurate with it as yet. Right, this is going to be my ground wire here. So I want to connect that between these 2 windings on my transformer. And what I'm just going to do is I'm going to measure the voltage on the output of the transformer as AC. And then we're going to spec up a transformer and see if it works. So that'll give us the voltage. We won't know the power rating yet because we don't know how much current the Linto is going to want to consume. So let me just tack this in place. This is only going to be temporary. This is not going to be the transformer that ends up in our Linto, because I don't think it'll fit, to be quite honest, but it'll do for testing purposes. I want about 14 volts on the main output, and I think about 10 on the other. But that's going to be lost in these resistors here. But like I say, there's so much post-regulation in it, and filtration as well for that matter. I'm not quite sure we've got to be that accurate about it. So that's playing into my favour here, really. Let's just tin that up. and that's going to be my 0 point, which is going to be in that position there. And then just for the other two, let's pick a yellow and something else. It doesn't really matter. It's what I've got. So that one we'll take to there. It doesn't matter which way around these go either, really. It's irrelevant because this is AC, and our bridge rectifier circuit should sort it all out for us. So there we go. Make sure we haven't got any short circuits there. And I want to measure the DC on the output. And I also want to measure the AC on the input. So we need to get another meter. Bear with me one moment. Right, I've got my other meter. This is set to volts AC. I'm just going to connect across one half of our primary. So what I'm going to do is I'm just going to wind this up, one to do a smoke test. So as we see that voltage come up, what I'm going to do is we need about plus minus 14 volts. So 14 to 15 volts, something like that. So my variac is on 0. I'm going to wind this up to transformers I know we can buy. So we can get a 606, which will be too low, I suspect. So it's 5 volts, 6 volts, and yeah, you can see on there we've got 7.5 volts there. We should have minus 7.5 volts on here. Minus 7.7, close enough. So let's just take that up to, I know we can get a 909. 7, 8. Close enough. So that's 9 volts. And that'll give us a DC output plus minus 11, nearly 12. Not quite enough. So we get a 909, we should be able to get a 12012. So there's 12 volts. There we go, 15.7. Don't forget this is off load, it'll come down a little on load. There's no regulation in here. Plus minus 15. Pin 4 should be 0 volts, which is our delayed switch on. And we've got another plus 15. Ground, and then minus 15. That needs to be about minus 10, the minus 9, something like that. And that's what these resistors are for. So looks like we need a 12012 transformer, but I'm just going to put the connector on, connect this to the Linto, sorry, and see what happens. Right, I've got the blown up Brilliant here. I need to transfer this connector off there onto this new PCB, and to do so we need to know which is pin 1. So thankfully 2 of the pins at this end connected together, and those 2 pins there connected together, so that's a ground. So that means this end up here is pin 1. I am just going to mark that with a Sharpie because we are not at home to Mr. Cockup. Okay, that is pin 1. I shall switch the desoldering gun on and let's get that desoldered. See what we'll do while we're waiting for that, we'll just put some fresh solder on there because everything's better with a fresh blob of solder. Pin 1 is that end. Pin 1 on my PCB is marked with a square, so that can go in like that. There we go. let's get the Linto and see what happens. Right, just to talk you through what we've got here. The output of the Linto is going to our test amplifier up to the workshop speakers. In line with each winding of the transformer, I've got these 2 meters, so we can have a look at the current being consumed and work out the power. The power, by the way, I did say it was going to be less than a watt. That's rubbish, because we've got linear regulators in here, and I bet you these are throwing away a watt a piece. So yeah, I reckon it's going to be north of sort of 4 or 5 watts. What else do we have? Oh yeah, we have a BSR UA14 equipped with the dulcet sounds of Sydney Devine. Sydney has unfortunately succumbed to being left on a shelf in the sun and has gained a warp now as well. So man, he sounds good. Right, let's apply some power. Yeah, so we got 450 milliamps in one leg at 122 in the other. I'd expect that to have been more symmetrical, but I'm not totally surprised. I got LEDs on our power supply, so that's good. Got an LED on the front, so that's good. Let's cue Sydney up and see if we get any audio out. Which we do. Excellent. Oh, God, it's rough, this LP. Ah, yes. The dulcet sounds of Sydney Devine. So that's good. Right, so 450, 722. That is just shy of 9 watts, isn't it? So, no, a little bit more than that. It's just over 10 watts. So that's okay to allow for a little bit of headroom. If we were to purchase a 15 VA transformer, we should be in the clear. Right, I'm just going to leave this on now for a couple of hours and check it all works all right, and then order up the appropriate transformer.
The very next evening.
So, yesterday evening I played my way through a couple of LPs, and yeah, it performs okay with one issue, and that issue is from here. There is a slight odour of nasty capacitor. So, yeah, I suspect it's these brown ones again. If you watch the Linn video, where I repaired a U25 Brilliant from a couple of weeks ago, you'll know there was a problem with those, and I think we've got the same issue again here, although it could be those surface mount caps there. That's entirely possible as well. Let me just pop the soldering iron on. Just need to disconnect that wire for a moment. We can then... Oh, I could have just taken the old board out, couldn't I? Fool. Right. So I'm just going to liberate the PCB. Put that out of the way. So these are the ones I think we're in trouble with. So yeah, let's put the desoldering gun on. We'll flow some new solder in there. Are they all the same way around? They are. Negatives are all pointing towards you over there. Right. Oh yeah. And there's the smell. They're leaking their unpleasantness. Yeah. Oh! Why do I do it to myself? All through there we have. Right, what's that? Well, you can see there's a bit of ooh nasty in there. 100 mic, 35 volt. Are they all going to be the same? hard to say. Let's do them one by one. I'm just going to get a cotton wool bud or a Q-tip and a bit of IPA and just clean up that electrolyte from the board. Let's take them all out. That last one's all right. The others, not so much. Polarity is clearly marked on the board anyway. Just get a bit of blue tack in there just to hold those down while I solder them up. Right, let's pop that back together. One thing I just want to see actually is that slightly different level of current consumption between the positive and negative on here. I just want to see if that has changed any. So I'm just going to power it back up and measure those currents again. Meters are set back to volts AC. Amps AC. No, we've still got that weird offset. All our lights are on the board, and hopefully that's solved the unpleasant smelling issue of those nasty capacitors. Right, we're waiting for the transformer. That's the next thing to fit. So, oh, and change that capacitor out. Right, it's several days later because RS for some reason decided they were going to put my account on stop because I hadn't supplied an order number. Yeah, I don't get it either. They supplied the first part of the order absolutely fine, but that all got stuck in processing for some reason, but we're all right now. It's quite early in the morning, by the way, because we're in the third heat wave this year, and it's already 27 degrees in here, which is hot enough for me, thank you. I have got the top light off because that's the biggest source of heat in the place. So yeah, right, I'm just going to fit this capacitor that RS have now supplied so I can get rid of my odd one. And the other thing I've got is some little fuses for protection for the transformer at the front here. Okay, that's looking almost complete now. That's good. I need to find some connectors to go in there. It's that or I can wire the transformer straight in there. Let's just get rid of that. Talking of transformers, the lovely people at Switch Electronics have provided this Vigatronics toroid transformer, which is just the job. So we need to get that mounted up somewhere along with our new power supply. So yeah, right, that's my little board complete. These two resistors, by the way, I changed out from 120 ohms down to 82 ohms to give the regulator on here a little bit more headroom. It was borderline, so that should now be good. So yeah, I've just got to mount everything up now. Now here's our switched mains. Runs down to the switch here and then back again, so that can feed the primary of the transformer. This is a voltage selection switch for 110 or 240, 120, 240. So that is sadly going to be redundant. We can only wire this one way. Yeah, so I'm not going to bother with that. It's only for use in the UK. Obviously, if you did want 60 hertz, 115 operation or whatever, you put these two windings here on this transformer in parallel. As it is, I'm going to couple those together, and that'll give us a 240 input there. We've got our low tension output here, which will feed the filter rectifier assembly. So yeah, we've just got to mount it all up now. Now the Vigatronics transformer comes with a mounting kit, so it's probably my first job is to get the is to throw the mounting kit all over the place. Right, we've got bolt, couple of washers, nut, some gaskets, and this top hat shaped washer. So that will fit over there, fit over the top of the transformer. That'll fit down there somehow. Just need to be a bit aware of where the case comes up to. I think the Brilliant just actually, yes, we need to be inside those legs, which will be fine. Okay, right, I'm just going to tidy a bit of that up. Let's get a zip tie and just tuck that voltage selection cable up out of the way. That's that out of the way. I need to remove that plug from there. Mains input, by the way, is fused inside the socket, so haven't got to worry about that too much. Next thing to do, I suppose, is just to prepare the transformer. So I need to put the two primaries in series for 230, 240 operation. By the way, the noise you can hear is a little fan I've put over there, just trying to keep me cool a bit. Right, that's those two in series. We need a bit of heat shrink over there. I'm going to put 2 layers on there for good measure. Yep, that's not going anywhere. Okay, so ideally I want my transformer to be as far away from all this lot as possible, and we've got quite a bit of wiring there, so I can come all the way to the front here really, and that would be ideal. So I think I'm going to drill my hole about there. So yeah, let's make that happen. Auto center punch. Give the hole a little deburr. Clean up the swarf. Let's see how this kit fits together. first of the rubber washers. Slip the transformer around. I don't want my mains wiring going off to one side like that, I think. Second of the rubber washers. Top hat. Washer. Nut. Get it all sort of centralized so it's happy. And then just tighten it down. That's that. I think the easiest way to make the mains connection here is to use a Wago. Nice and simple, nice and strong. This is the sort of Wago that I refer to as the Chinese finger trap. That's it, good solid connection. Next thing we've got to do is mount the PCB. So thinking something like that should do us nicely. Right. I'm going to go and get another unpopulated PCB and use that as a drilling template for the bottom. Right, I think I'm going to go something like that there. Yeah, let's hold that down a bit with some blue tack. Try and get it straight as I can. Forgotten my sacrificial piece of wood. Now, not sure I've got any standoffs. So I might have to 3D print something, but I will just have a little look in my box. In fact, one thing I am going to just do is just drill those out slightly to the next size up, just to give myself a bit of room. Little bit of wiggle room. Oh no, I've gone through the inscription. Not got enough standoffs, so I'm going to 3D print some. Appears my 3D printer doesn't like the heat either. Well, I shall clean those up a little bit. Thought that might be the case. I've made the holes slightly too small in the PCB. There's plenty of meat around them though, so I'm just going to drill those out. I think I've made those standoffs a little bit too standoffy. I'm going to make some shorter ones.
15 minutes later.
Oh yeah, that's much improved. Yay! Right, quite happy with that now. Let's just tidy this mains lead up. A couple of zip ties, I think. And then we've just got the AC to make work. There we go. Right, final test. Right, well I've got it all set back up again. I've got a bit of mains coming in. I am on the variac because I just want to make sure we've got everything right before going mad. So yeah, power is on and volts going up. Not consuming any silly current, so that's good news. Right, we're at full mains and I've got nothing. Now bearing in mind that that Brilliant had obviously failed with some gusto, I wonder if the mains fuse has failed, so let's just have a little look at that. Come out, swine thing. That'll do it, there's no fuse in there. Right, let's find a fuse. Right, I've gone with 630 milliamps, enough to prevent any unpleasantness going on, and also provide enough inrush, because we're running a toroid and they generally have a little more inrush current than an ordinary sort of chassis transformer. Right, mains power is on the front, and we shall turn our variac up again. Yeah, we've got an LED this time. Okay, that's good news. Let's go with the dulcet tones of Sydney Devine. Oh. Brilliant! Well, as far brilliant as Sydney gets. Yeah, no, that's working fine. There's no noise from there. The delay and everything's working fine. I'm really pleased with that. Right, what I'm now going to do is just leave it on for a couple of hours just to make sure nothing gets overheated, despite the fact it is now 29.8 degrees in here. Yeah. I'm just going to leave that running. Right, pop back in a bit. It's been running now for a few hours and performing great. I was a little bit concerned about heat, so I've got my thermal camera out, and sure enough, I don't know if you can see it on the top camera there, but those dropper resistors here are getting quite warm, but actually they're no warmer than the little surface mount ones here on this main board, so I'm not really concerned about that. The only thing I am concerned about is it's warming up the capacitors slightly, so I'm just going to power off, and what I'm going to do is I'm actually just going to bend these out a little bit So it's a bit more distance between these capacitors. I mean, they're barely warm to the touch. But the other good news is transformer and everything is running cold. Everything else is working just fine. So yeah, I'm just going to wait for those to cool down a little bit, bend them out of the way, and then button it back up. There, I think that's a much better solution. So yeah, I'm pronouncing this one fit. So let's get the screws back in the case. I've got 2 screws left over, but they were the ones that secured the original Brilliant back in. So not worried about that. That's it. Wonderful. A Linto, unbrillianted and saved from landfill. Thank you very much for watching. Click like, subscribe, do all that rubbish, and I'll see you really soon here on Doz's Television Workshop. Cheers now. Bye.
Does in the garage with his tools all laid out. Sparks fly from the wires as he figures it out. This old phonoprene got a mind of its own. Trying to bring it back, it's a labor of love. 'Cause I'm a little bit weary, a little bit slow, but I'll get it back on you. You don't wanna be like me, this fix takes some time, always chasing that sound. Old records are playing while the sun fades away. He's humming a melody from the good old days. With every connection, he's feeling the groove, rekindle the memories with each little move. Well, the bright big sharp scars, I'm in the middle of be now, dressed for some new. You ain't go like me, I'm burning round. Sorry to dawn, I got out. So here's to the music and the stories it tells on the journey with his tools and the bells. I'm a little bit weary, a little bit slow, but I'll get it back home. You don't wanna be like me, this fix takes some time, always chasing that sound.